Hello everyone, am I audible? Can you all
Yes,
hear me?
ma'am. Yes, ma'am.
Okay. So I will be sharing the screen. First of all, we will be starting with one topic in Python. We will see how to handle missing data using Python. Okay. So one minute, I will just show you all the screen. Share the screen with you. Is the screen visible? Can all of you see the screen?
Yes, ma'am.
Okay. Very few people are replying. Can just give a thumbs up or something.
Yes, ma'am.
I will understand if people are listening to me. Okay, fine. Okay, chalo. So I will just show you all the data set that I will be using for this practical. So this is going to be my data set. I will show you all the data set directly from my machine. It is already downloaded in my machine. So my laptop is a bit slower, so you have to be patient. Okay, finally it has opened. I hope that all of you can see the screen of WPS and the file is getting opened. The CSV file is getting opened. So this is the data set. So the data set, as you all can see over here, it has some four columns in it. The first column is the region column. Then the next one is the age column. Then we have income and online shopper. But as you can see over here, that the age column has one missing value. So you can see that the missing value. One minute. The missing value is over here in the age column at the 8th position, whereas in income at the 6th position. Can all of you see the missing value? These two?
Yes.
Okay. So now we are going to see how we can fill the missing value with the help of Python coding. Okay. Have all of you understood what we are going to see in this practical? Yes. Fine. Okay. One minute. Let me take them in. So yeah, I will open Colab now and I will start doing my coding. So now as Colab opens, the first thing that I will be doing will be uploading the data set, that is data1.csv, and then with the help of pandas we will read that CSV file. Okay. So I will just increase the font. I hope that you people are comfortable with this font. Let me just type something. Is this font okay or should I increase the font more?
Can you increase it a little bit more?
Just check this one.
Yes, ma'am. Work. Thank you.
Okay, one minute. Huh? I will just share the tab now. so that it will be more convenient for you all. Okay. So we just change the title practical to missing data. And also we are going to do some visualization. So I will just give the name missing data underscore visualization. All of you can just note down whatever I am doing now in the practical and you can perform it tomorrow in front of me. Okay. Now we will upload the file. So my file is data1. So yeah, this is my file. Okay, so the file is uploaded. We will just check it once. So yeah, this is the same file as you can see, region, age, income. So yeah, now it is done. Now I can import pandas and I can start with my practical. So import pandas as PD will be my first line. Now I will just read the CSV file and I will make my data frame. So df is equal to, and I will write PD dot read underscore CSV, read underscore CSV. We'll make a bracket and we'll give the name of the file, that is data1 dot CSV. Just execute it and we will just check if the data frame is created properly. Now since the data frame is quite small, it just have 9 to 10 samples in it, so I will just print the entire data frame over here. So as you can see that yes, my data frame has come fine, and all the missing values as you can see over here, they are given by NaN. Okay, so hope so guys, all of you have understood till here properly. There was nothing new in this.
Yes, ma'am.
Okay. So now we shall move a bit further and we will see that how we can handle the missing values here. Just 1 minute. So for handling the missing values, there are different strategies that we can use. I'm teaching you all the use of one library called as Imputer. So how we are going to get access to this library? So we'll write from sklearn dot dot impute. Okay, so you can see the help from sklearn dot impute import, and then the name of the library will be simple impute. So this is the library that we will be using for handling the missing value. I'm going a bit slow so that all of you can, if you want, all of you can just note down whatever I am doing. Now we will make an object of this imputer. So we'll give the name of the object as imputer. Imputer is equal to, and then we will just copy paste this. Just copy it from here. That is the name of the library, and paste it over here. Now make a bracket. Now the reason why I'm teaching you all how to handle missing value using this library, because it is a versatile library. No matter whether your column which is having missing value is a string column or a numeric column, it can handle all of them. So that is the reason I'm taking the example of this library to teach you all how to handle missing values. Okay. So first argument that we are going to pass is missing underscore values. This is the first argument that we pass. And through this argument, we tell the simple imputer that what is the indication of missing value, like what exactly is the missing value. So 1 minute. Now I will just show you all the data frame. Now in this data frame, you can see that the missing values are given by NaN. Okay, so we will tell the simple imputer that the missing values are nothing but it is numpy np dot nan. Okay, so this will be an indication. Through this, wherever the imputer it finds the nan, it will understand that okay, this is a missing value. Now what is np? Np is basically a small name for numpy library. So I have to import numpy here before doing this, because this keyword nan keyword, it is present in the numpy library, so that is the reason we have to import numpy over here. Okay, now once we are done with this, so we have told the imputer that how it can recognize the missing value. Now we will tell the imputer, like how it can fill the missing values. Okay, so for that we will make use of this strategy. Sorry, I hope all of you can see what I'm typing. So strategy, with the help of strategy, we can actually tell the missing, tell the simple imputer how it can handle the missing value. Now there are different strategies, but the most commonly used strategy is most frequent. Now, why I am telling that it is the most commonly used strategy? The reason is that whether you are having a string column or whether you are having a numeric column, most frequent value will be there. So the simple imputer will see that in that column what is the most frequent value, and it will use that most frequent value to fill the missing value. Okay. Now there are other strategies also, like say for example you can make use of mean, you can make use of median. So we can definitely make use of different statistics also. But though if we are making use of mean and all to handle the missing values, then in that case we have to make sure that we are applying it only on the numerical column. Okay, so yeah, we'll just run this now. So yeah, see, we have created an object of simple imputer called as imputer, and we have told that the missing values can be recognized through the nan keyword. Now, because the nan keyword comes under the numpy library, so that is the reason we have given numpy.nan, and we have given the strategy that for handling the missing values, the strategy which is supposed to be used is most frequent. So in whichever column missing values are there, most frequent value of that column should be found, and the missing values should be replaced with the most frequent value. Okay, now we'll just go through the data frame. Df was the name of the data frame, right? And we'll just see the number of missing values.
Ma'am, your screen sharing has ended for some reason.
Screen sharing is what?
It, It's stopped. We can't see your screen.
Okay. No one can see my screen.
No, ma'am, it's visible. You are typing in the sixth row, right? Like df.isnull, right?
Yeah, yes.
Yeah, yeah. So, I mean, it is visible.
I don't know. I think that there must be some network issue at your end then. Just try to connect to the meeting again.
Okay.
Okay, make parenthesis. And now we have to put dot sum. Dot sum. And shift enter. So see. So this tells us that we have missing values in two columns. So which are the two columns in which we are having the missing values? So we are having the missing values in the age column and in the income column. I hope everyone can see this, right? So since we have the missing values in both the columns which are numeric in nature, so as I told you all that we can make use of the strategy most frequent when we are not sure that only 1 minute. Yeah. So what I was saying is that we can make use of the strategy most frequent, when we are not sure that all the columns will be numeric columns. If we are having a mix of, string columns and numeric columns, then we can apply this strategy. But as you can see over here, the missing values, one missing value are there, and they are there in the numeric columns only. So what we will do is, in this practical, first of all, we will apply this imputer to our data frame, and we will see how it fills the missing values, and then we will make use of some other strategy also. Okay, so that you will get to know both. So what I will do is I will make a new data frame df1. Okay, and now we'll write df1 is equal to our imputer. Imputer was the object that we have just created up. So this was imputer. This was the object that we have just created, and then we will use a dot notation. Okay, so a dot notation, and then fit transform is the function that we will apply, and our input data frame will be df. Okay, so what we are doing is we are giving df to the imputer. So what the imputer will do, imputer will check where are there nans means missing values. Okay, and wherever it will find out nans, so for example it is going to find out one nan in the age column, and it will find out one nan in the income column. So what it is going to do is it will fill that nan with the most frequent value. Okay, let's execute and see. So we'll execute this. So it has been successfully executed. Now let's check the output. So as you can see over here, see there are no missing values. All the missing values have gone. Where was the missing value? Let's just check. So the missing value was in Brazil and in US. In US, income was missing, and in Brazil, age was missing. Okay, so see now this income is there, and then age is there in US. Sorry, in Brazil. In US, income was missing, and in Brazil, age was missing. So you can see that it has been filled. Okay, I hope so, guys. Everyone have understood till here properly. I will just revise the code again. I'm trying to go as slow as I can. So see what have we done here. So we have imported pandas, After importing pandas, we have read the CSV file and we have made our data frame. The name of the data frame is df. And then afterwards, for handling the missing values, here we are making use of the simple imputer library, which is there in this module. Okay. And then we are creating an object of simple imputer. So how we are creating an object? We are telling the object that the missing values can be recognized by the nan keyword, and wherever you find the missing value, just fill it with the most frequent value of the column. Now, why I am using this strategy? Because I am not sure that only the numeric column will be missing. Maybe the string columns may also have missing values. So that is why I am using this strategy. Now after that, I'm just trying to find out that there are how many missing values in each column. So you can see that only two columns have missing values. That is the age column and the income column. They have one missing value. And then afterwards, as you can see that I have applied the imputer on my data frame and I have created my new data frame, and the missing values were gone. There are no missing values. I hope no one can see any nan here. Understood now, everyone? Have all of you understood this? Ria, are you trying to say something?
No, ma'am, got it.
Okay. Don't think many people are replying. If you can just let me know in the chat, have everyone understood this properly? Anam Sheikh, Lubna, Samad. I don't know who was not able to see my screen. I hope that person is able to see the screen now.
Yes, ma'am.
You have understood the
ma'am.
code?
Yes, ma'am.
You people are not finding it difficult now? The strategy that I have taught you all to handle the missing value, you are not finding it difficult now? Please tell me frankly if anyone is finding it difficult. Samad is there or not?
Ma'am, he just messaged me. He's there. Yeah.
Yeah. Okay, fine. So since you people have understood this, now I will teach you all another strategy. Okay, and that is not going to be difficult at all. Just copy paste this, Control C, and we'll do a Control V. Okay. We'll make a brand new object, imputer1. Okay, the earlier object name was imputer. So this simple imputer object is named as imputer1. Now, rather than using the strategy most frequent, okay, now I will use the strategy mean. Okay, mean. You can also make use of median. Fine. Mean and median both are allowed. Now just run this. So what we are trying to do with this imputer? We are trying to say that this nan, it represents the missing value, right? And whenever you find the missing value, I mean this imputer one, wherever it finds the missing value, it should replace it with the mean of the column. Now why suddenly did I decide to do this? The reason is, if I show you, that df.isnull.sum, wait, I will just show you all. See. There were one missing values in the numerical column. So if the missing values are there in the numerical column, why don't I fill the missing values in both of this column using the mean? Because that will be the most intelligent way to do that. Okay, rather than taking the most frequent. Most frequent should be used when we are dealing with the string columns. Now, since we have numerical columns and we can calculate the statistics like mean, median, and all. So now I have decided that I will make use of mean. Okay. So now what we will do is, now we'll make a new data frame, and for that we'll just copy paste this code. And we'll just name this as df2 and here imputer1. Okay. So what imputer1 will do, it will go across one columns of my data frame, and it will see that are there any nan, if it find any nan in any column, so it will replace that nan, that is the missing value, with the mean of that column. Okay. Now let's execute this. Okay. Now see, it is giving me error. Let me just check why it is giving me error. One minute. I think someone is trying to get in the meeting. I think a lot of them are facing network issues. In between, many people are trying to get in the meeting. See again. Okay, anyways. So yeah. So since it is giving me error, so I will just try to apply one strategy here. I will directly mention the name of the columns that have missing values. Okay. So I will just write df.columns here first of all. And I know that age and income have missing values, so I will just copy paste them. Now, how do I know that age and income have missing values? From year, right? Now we'll try to execute this. Let's see if it works now or not. Yeah, so by God's grace, it has worked. So now df2. Let's see df2 now. So as you can see over here that it hasn't worked properly though. See, all the ages it has replaced. Something wrong has happened here. We haven't got the perfect output we were looking for. We'll just try to apply it on one column at a time. Let's see. Okay, let me just check. I think there is some issue with this code. I will come up with the correct code tomorrow. Let's not just waste our time in this. So we'll just work on this. We'll continue with this in tomorrow's offline lecture. So in the meanwhile, just do the code till here only, okay? Because if I just try to sort out the code and all, it will take time. Okay. So yeah, guys, hope so. All of you have understood this practical properly. Okay. So here we have you made use of simple imputer to handle the missing values. How we have used simple imputer? Hope so all of you have understood this. Okay, now what is the problem? Like why people don't use this library? What reason do they give? For not using simple imputer? The reason they give is simple imputer converts the data frame into an array. See, what I gave as an input to the imputer, I gave the data frame as an input to the imputer. But the imputer has, obviously it has handled the missing values. But as you can see over here, it has converted my data frame into an array. So, then again I have to convert the array back into the data frame. So people don't like to juggle, in between the data frame and the array. So that is the reason that simple imputer is not liked much by people. So what is the another option that we are having? Okay, so now I will just show you all the another option. So the another option is to make use of pandas filna function. So we'll apply the filna function. I will show you all how to apply the filna function. So because filna function is a function which is provided by pandas itself, so we can directly use the data frame, and we can directly apply the filna on the data frame. Okay. So this is the function filna. Okay. Fill means wherever it is finding a nan value in the data frame, this function fill it will fill it. Now how it will fill it? So I will just give df dot mean. Make parenthesis and just try to run this again. Okay, now we'll check the data frame once. Huh? I think there is some problem with the data frame. We'll specify the name of the columns otherwise. So the columns were age and income. Let's see if this works. So this has, see what we are getting as output. Okay. So this is perfect. So as you can see over here, the age and income now, they are filled with the mean values. Okay, so this is another way of filling the missing values. That is the filna function. The advantage of using filna function is it takes as an input the data frame and it gives as an output the data frame. Okay, so yeah, because there was some confusion in between, we got the wrong output and all, so I am just repeating the things again. Okay, so I will just remove everything which didn't work and we'll just keep only those things which work properly for us. So for handling the missing values, we saw that in our data frame we had two missing values. One was in the age column and another one was in the income column. So for handling the missing values, the first thing that I did was I made use of the simple imputer library, and I told simple imputer that wherever you find nan, consider it as missing and replace it with the most frequent value in that column. Okay, and it worked fine. But with mean it's not working. I just need some time to see why it is not working. I will come up with the code tomorrow. Anyways, but the problem with simple imputer was it was taking the data frame as an input, but what it was giving as an output was an array. So when we gave it df was actually a pandas data frame, but it gave us df1 in the form of an array. Okay, so if we want, that the output should be in the form of data frame only, then rather than making use of simple imputer, we can make use of pandas filna function. So as you can see that what filna will do, filna will take the data frame only as an input and it will return the data frame. So like over here, I told filna to take the age and income column from the data frame, and then wherever missing values are there in the age and income column, replace it with the mean. And it has done it fine and it has given me a data frame only. Okay, so yeah guys, I hope all of you have understood till here properly. Let me know in the chat if there is any confusion or anything. We will sort it out tomorrow, but whatever has worked fine, hope so everyone have understood till that part at least. Aditi, Khushbu, Prerna, have you all understood this?
Yes, ma'am.
Okay. Now we'll do a bit of data visualization on this data frame. So I will just show you all how to do the data visualization. So let's start. For doing data visualization, we are going to make use of the library called as matplotlib. Okay, so import and put a space. The name of the library is matplotlib dot. Okay, and we make use of the pyplot module from this. So pyplot, and we'll just give it a small alias name, so that calling this becomes easy for us. So it will be plt. Okay, just run this. So this is the library which is used mostly in Python to do visualization. There is another library also called as Seaborn, but I thought that Seaborn will be difficult for you all, so we will just work with this library, a small and easy one. Okay, so yeah, let's start with the plotting. So as you can see over here that I have given a small alias name to matplotlib.pyplot. So I will just use this alias name. Okay, and what we will do is, first of all, we will do univariate analysis. So for doing univariate analysis, we can create a histogram. Now since it is a univariate analysis, we can mention the name of the column that we on which like we want to do the visualization. So over here I am taking the age column, and let's just run and see what kind of output are we getting. Okay, so this is the output that we are getting, which is not looking that fine. Okay, so see here, it has taken the bins and all very vaguely. So we'll just try to make it more polished. So we'll put comma here first of all, and then we will give bins equal to 10. Okay, and yeah, so that's it. I think this should be sufficient, and then we will just decorate it with some labels. So we'll give some title with the help of plt dot title. Give it the title as say age distribution. Now X and Y label. So or definitely on x-axis we will be having age, and histogram is used to show the frequency. So we'll give the Y label. Sorry, it's a bit typo here, but I will just copy paste the code from here. Okay, let's see what kind of output we are getting. And if you want, you can adjust the figure size also. That also I will show it to you all. Height and width. So PLT dot, you can just write figure. So where is this dot gone? Okay, so PLT dot figure, make a bracket, and if you want, you can adjust the figure size. So figure size equal to, and then in the bracket we can set the height and the width. So 6 comma 4 I am giving as of now. Let's see how it looks. Need to just close one more bracket here, and it's proper. Let's just run this. Okay, so this is how it looks. This way, I will just decrease the font. So you can see here that now it has taken the labels and all properly, and it is now looking fine. Okay. Now, if you want to do it, I mean, if you want to create the histogram for some another column, say for example, if you want to create the histogram for income, so just give income here. And over here also, wherever age is there, we'll just replace it with income. Just okay. So yeah, this is the histogram for income. So in this way, we can create histogram using Python. So creating histogram in Python is simple. As you can see over here, we just need to call the hist function, and in the bracket, we just need to mention the name of the column of which you want to give the histogram. Bins is equal to bins. If you give or you didn't that do not give, it will almost show you the same output. Actually, I think it is better to explain bins in the offline lecture, so that's why I'm not focusing much on bins now. And then we can just decorate our plot by giving it title and X label and Y label. Okay. And this is again optional. If you want, you can set the figure size, or else you can run it as it is, because nowadays this Google Colab and Jupyter Notebook, they are smart enough, they can adjust the figure size. So it is okay if you do not give it. I was just showing to you all that whenever you are doing any plotting, and if you want to adjust the figure size, so that also you can do in this manner. Okay. So yeah guys, I hope so that you people have understood how to make a histogram for individual columns. So this is an example of univariate distribution. Have all of you understood this? At least 0.2%, 2% I can say, a bit. Okay, now we will make scatter plot. Fine. So now we are going to do bivariate analysis. We will not go till multivariate analysis. We will just go till bivariate analysis only. So for making a scatter plot, you have to write PLT. Like for making a histogram, you have to write PLT dot hist, right? So similarly, for making a scatter plot, you have to write PLT dot scatter. Then make a bracket, and then afterwards just give the name of the columns. So whatever column you want on the x-axis, so say for example on the x-axis I want age column, okay, and then we will give a comma here, and say on the y-axis we want the income column, like this. Okay, so yeah, that's it. And if you want to give a title, you can. I will just copy paste the title ka code from here only. 1 minute. I have already written this code, so we can just copy paste this. And we can give it the name, say age versus income. Age versus income. Okay. And here on the Y label we will have income, na? And on the X we have taken age. X we have taken age. Okay, let's just run this now. Okay, so you can see this is the scatter plot of each and every of the data point by taking the age on the x-axis and by taking income on the y-axis. And what does it show me? See, it is somewhere or the else it is trying to show me that age and income are having a linear relationship with each other. If you can just see this graph properly, na, see, if I can draw a line across these points, right? The inclination of the line is in such a way, the inclination of the points is in such a way that the most suitable geometrical shape across these points will be a line. So through this scatter plot, we can understand that age and income are actually having linear relationship with each other, which means that as age increase, income can also increase. Okay. So yeah, guys, this was about the Python visualization. I have tried to keep it as simple as I can. So we have seen how we can make use of the matplotlib library basically to do a visualization in Python. And we have seen two types of visualization. Univariate visualization with the help of histogram. We have seen how to create histogram for single columns, and then we have seen bivariate visualization through scatter plot. We have seen how to make a scatter plot with two columns. Okay, have everyone understood this? I hope you people haven't find it that difficult. Vijay Lakshmi, have you understood this?
Yes, ma'am.
Okay, Purnima,
Yes, ma'am.
Kushi,
Yes, ma'am.
Ayush.
Yes.
Okay, no difficulties now. Like whatever we have done till now, you people haven't found it that difficult, right?
No, ma'am.
Okay, fine. So shall we stop here, because my whatever I wanted to teach you all regarding handling of the missing values and visualization in Python, that I have done, and whatever error is there I will just sort it out, and I will show you the entire code again tomorrow. So Python ka thing is done. Fine. The next thing was a bit of MySQL queries. Actually, I wanted to show to you all. I think we have done till insert data insertion. We have completed now.
Yes, ma'am.
Okay. So I just wanted to show you all a few update, delete and select queries. It will take more half an hour. Is that okay with you all? Please feel free to say yes or no, whatever.
Yes.
Yes.
On chat, everyone, yes or no, please put it. I'm okay with your answers, whether it is yes or no.
Yes, ma'am.
Oh, Rishikesh. Fine. I'm just sharing the screen. Just check if the MySQL tab is visible. Is the MySQL screen visible to everyone? Oh,
Yes, ma'am.
start. Okay, fine. So I have already created all the tables. Okay, I will just show you all that. So our first table is the customer table, right? Uh, I was not having the exact data which I gave to you all during lectures, but you can see that I have created the customer table. Then I have created the branch table. Okay. Yeah. Then I have created account table. Sorry. And then this is the next one, deposit. I think these were the four tables which we have created in the offline lectures. I just tried to create all the tables again, and I have put data only in the customer table. So I will be showing you all the queries only with respect to the customer table. Okay. So, how to see all the data from the customer table? I think this query we have seen in the offline lecture also. How to see all the data from a certain table? So we just need to write select and star from and then the name of the table. Put a semicolon and enter. Okay. So select query is basically used for reading the data from the table, and if you want to read all the rows and all the columns from the table, then you can give select star from and the table name. Okay. Now what if I'm just interested in the customer name? So I will write the same query, but just I'm going to replace the star with customer name. Okay. So I will write my query in this way only if I am not interested in all the columns, but I am interested in a specific column from the table. So over here I am just interested in the customer name. So you can see that in the output I have just got the customer name. Okay. Now suppose I am interested in customer name as well as age, so I want to see two columns. So then you can just write customer name comma age as Okay, it is cust underscore age. I have just written the wrong column name. So cust underscore age. Okay. So yeah, guys, I hope so people have understood this properly. So I will just repeat it again. So if you want to see all the columns and all the rows from a table, give select star from and the table name. If you are just interested in one column from the table, right, select the name of the column and from the table name. If you are interested in more than one columns, so you can write the name of the column. So over here I was interested in customer name and age. So write the columns, whichever columns you are interested in, by putting comma in between them. Okay. So hope so you people have understood the difference in the three queries. The first one was for retrieving all the columns from the table. The second one was for retrieving one column from the table, and the third one was for retrieving two columns from the table. Okay, now let's talk about the row selection. So suppose I want all the columns from the table, but I'm interested in just one row. Which row? Suppose that I am just interested in Priya's row. Okay, so then I can write the query in this manner. Select, since I'm interested in all the columns, so I will write select star from the name of my table, customer. Okay, where so since I'm interested only in Priya's row, so and the customer ID of Priya is 3, so I can give like this, where customer ID equal to 3. Okay, put a semicolon and so you can see that I am getting all the columns from only one row. So basically whenever you want to do row selection now, so you have to make use of where keyword, and after where you have to write the condition. So whichever row will meet that condition, you will get to see only those rows in the output. Okay. Now, what if I was not knowing the customer ID of Priya, but I was knowing her name? So then in that case, I will just write here customer name is equal to Priya. Okay, and Priya definitely, because it is a string, so it will be enclosed inside single quotes and like this. So see, the output is same. Okay, but here the condition was that I'm interested in all the column of that customer which is having ID 3. And over here I'm trying to say that I'm interested in all the columns of that customer whose name is Priya. Okay, so yeah, but since in this table we were just having one Priya, so that is why over here we have got just one row as an output. Had there been more than one Priyas, and I will just show you all that also. So suppose I am putting one more row in the customer table with the name Priya. 1 minute, we'll be having the insert query. So suppose I have put here 5th customer with the same name Priya. So this Priya lives in Pune. Let the other Priya with age say 1 minute. Let us just change the age to 45. Enter. Okay, we'll just do select star first. So now you can see we have two Priyas. Okay, now I will just run this query. Select star from customer where customer name equal to Priya again. So now you can see that because in my table there are two Priyas, so that is why it has given me two rows as an output. But when you query based on customer ID na, so I will write that same query again. So because customer ID is unique for every row, so you will just get one row only as an output. Okay, so that is the advantage of writing the query on a ID column, because generally the ID columns are primary keys na, so primary keys are unique, as we know. I will show you the table also, customer table. So look here, in my customer table, customer ID is primary key. So that means that every row will have a unique customer ID. So if I query based on customer ID of Priya, I will get the record of proper Priya. But if I query, based on her name, where customer name is equal to Priya, so because customer name is not a primary key, it can be repeated, right? So whatever number of Priyas are there in my customer table, it will give me all the records of all the Priyas. Okay. So yeah, guys, hope so. You people have understood the queries till here properly. Now, suppose that I am interested in knowing age of Priya. Oh. So here I will just give age rather than giving star. Okay, because I'm just interested in one specific data, so I will just give that. So why it has given me two values as an output? Because we are having two Priyas. So it has given me the age of both the Priyas. If suppose that I'm interested in only the Priya with customer ID 3, so then rather than writing name, just give customer ID equal to 3. So it will give me the age of that Priya who is having customer ID 3. See, 25. Okay. And if you want to know her city also, so then give comma customer.
कभी मिल तो तुझको बताएं हम, तुझे इस तरह से सताएं हम।
Brew Gold made irresistible. Hand-picked beans roasted to perfection. Freeze-dried to preserve the intense coffee taste. Indulge in the rich flavor and aroma because it's not just a coffee, it's a spoonful of luxury.
विवेक आप गए नहीं?
सर वो
बेटी का टूर्नामेंट था ना आज?
मीटिंग है सर।
This is one of the most isolated supermarkets on Earth. But it sure doesn't look like it. After all, it's in Hawaii, which, despite its name recognition and visitor count, is by most definitions it seemed manageable at first. On the Monday before Christmas, as Winter Storm Elliott began to build, Southwest Airlines management huddled up to formulate a plan. The following day, it went into motion. After internal deliberation and after informing the pilots union, Southwest HQ began canceling flights in advance of the strengthening storm. The notice first directed customers at these airports to check if their flight had been disrupted. Then, the list of airports began to grow. So, the airline started the process of canceling flights by the hundreds. As the winter storm worsened, that call proved worthwhile. In fact, with the benefit of hindsight, they didn't go far enough. But the assumption that undergirded the decision to cancel, that they could process the cancellations early enough for customers to pivot plans and crews to reposition for new routings, proved utterly, devastatingly wrong. You know the rest of the story. Temperatures plummeted, thermometers across Denver plunged 37 degrees in a single hour, foiled travel plans ruined holidays, 5,700 flights nationwide canceled before Christmas, and while other carriers staggered along, Southwest crumbled into crisis, ultimately canceling nearly 17,000 flights and losing out on an estimated $825 million in the final 10 days of the year. It was the biggest meltdown of its kind. Some blamed the storm, others blamed the carrier's point-to-point model, while others still blamed the company's culture. But as time let the hot takes cool, a less exciting culprit came forward. A culprit that's hardly unique to Southwest. A culprit, in fact, that's less a bug and more an inherent flaw within the industry. While the biggest, the meltdown wasn't the first, and while an embarrassment to Southwest alone, it was hardly a crisis unique to the big, beloved budget airline. For Southwest, Winter Storm Elliott may have set the stage for the meltdown, but it didn't cause it. As much as anything, Southwest meltdown was a function of legacy. Southwest made its name as the pioneer of the low-cost business model through quick turnarounds and point-to-point route networks. While a typical airline will fly their plane out and right back into their hub, a given day for a Southwest aircraft might start in San Diego, then continue to Sacramento, Denver, and Nashville before finishing up in Tampa. Through this network structure, Southwest could offer non-stop flights where competitors only had one-stops, and by exploiting this niche, grew into the world's sixth largest airline. But while efficient in perfect conditions, this system becomes a liability in the event of a delay or cancellation. Pilots time out, crews don't make it to their expected destination for the evening, and planes aren't positioned in the right place for the next day's flight. But weather and unforeseen circumstances, as they always have, exist. So Southwest has tools for these situations, one of which is a GE aeronautics system called SkySolver. plug data into SkySolver on irregular operations, and its algorithms will, in the words of its brochure, execute flight schedule changes and cancellations, conduct aircraft routing and equipment swaps, and make fixes to crew assignments and pairings. That means that if a developing storm was to roll over Denver and cause Southwest to cancel this inbound flight from Sacramento on account of the risk that the plane and crew will stay grounded by the weather, it would call on SkySolver to effectively stem the bleeding and make sure that problems don't cascade to impact the rest of the routing. After arriving in Sacramento, rather than heading to Denver, SkySolver might send this plane on a passengerless deadhead to Nashville, where the crew now nearing the end of their workday could time out and hand the plane over to the next. Of course, that's only the beginning. While finding the most cost-efficient solution is simple in the context of this single routing, it becomes orders of magnitude more complicated when considering the hundreds of additional Southwest flights passing through. Like where to reposition the 737 that normally would have been running in and out of Denver all afternoon that has both the space for the plane and can begin running services the following morning. Or what to do with the 737 that is running flights between cities in the storm's path and thus is at risk of getting stuck in a snow-damned airport. And how to make sure the later legs of this routing get flown when the plane meant to run it won't make it out of Denver that morning. Now, SkySolver is powerful enough to run up to 300 batches of cancellations in 20 minutes, but does have limitations. First, it creates solutions to cancellations on the assumption of a static baseline. For it to figure out viable alternatives if half of Denver's flights are canceled, it needs to know that the Sacramento to Denver flight has already been canceled, and if it doesn't, or if the flight is canceled while the system's running, SkySolver solutions become less tenable, requiring reruns or manual intervention. Second, SkySolver is also limited by the data input into the system. Some of this data comes from an internal tool of Southwest's called the Baker. Dispatch processes delays and cancellations through the Baker to reconfigure routings for aircraft and passengers before the information is then plugged into SkySolver. Crucially, what the Baker's data lacks is crew information. Who's available, where, when, and for how long before they're timed out. Now, if the storm worsened and the number of cancellations increased, the limitations of Southwest Solver collided, resulting in a massive tailspin. With crews left out of the equation, the algorithm's output provided what thought to be viable solutions, but solutions without pilots and attendants. Once these flights had to cancel close into departure time when it became apparent that they only had half a crew, everything else unraveled as these new cancellations altered SkySolver's baseline assumptions. Effectively, the software's blind spot transformed the expected difficulties of a winter storm, hundreds of flights canceled at least 24 hours out on the 20th and 21st, into a full-blown crisis where Southwest tools worsened problems they then tried to fix, only to worsen things further. Through Christmas, cancellations occurred closer and closer to departure time as pilots arrived to planes with no flight attendants, while planes with no passengers deadheaded on circular, nonsensical routings like this as the software essentially panicked, positioning and repositioning planes only for the crew to time out and get stuck once again. Finally, blind as to where their own crews were, and with flawed programs providing flawed fixes, Southwest went manual, training volunteer staff at headquarters on how to process pilot and flight attendant forms and preparing for a hard reset. In the 4 days following Christmas, Southwest would cancel an incredible 10,700 flights, all because the airline failed to address a weak point that they had already identified. They had put too much pressure and stacked up too much complexity onto a fragile IT system that everyone already knew needed an overhaul. And yet, as the calendar flipped, as Southwest began to stabilize, and as more detailed reporting on the meltdown began to emerge, a new meltdown stole the spotlight. Now, it was the FAA that issued a nationwide ground stop. For 90 minutes, no commercial flights took off, and for the first time since 9/11, American commercial aviation came to a complete standstill. All because a single software update went sideways, leading to important pre-flight safety communications having to be relayed manually until they could simply no longer keep up with the morning rush of flights. And the cycle began again. Upset customers, outraged press, and promises that the old technology that everyone knew would fail would be looked into. And this pattern didn't start with Southwest, either. IT meltdowns hit British Airways in 2017, then in 2019, then again in 2022. They forced Delta to cancel thousands of flights in 2016 and 2017. They pushed American Airlines to cancel over 1,000 regional flights in 2018. All said they do better the next time, and yet all still rely on outdated, overstretched IT systems that were never designed to handle the volume of industry growth in the decades since their initial development. But the problems of old, overstacked IT systems don't stop at the back end. While customer-facing systems might look good on the surface, the most important one, the very system that makes it all possible, was created as close in time to the Wright brothers' first flight as to today. When a traveler sees this, it may look modern, but what they're actually looking at is a translation of this. Behind the scenes, Google Flights entered a query into the global distribution system, an interconnected set of softwares run by Amadeus, Sabre, or Travelport. In fact, specifically it entered this: AD to initiate an availability lookup, 08FEB to indicate the date, then DEN LHR to specify Denver as the origin and London as the destination. This initiates a query from the GDS system to another, OAG, which essentially acts as the definitive source of airline scheduling data worldwide. The GDS then comes back and spits out two options, one by British Airways, one by United. The strings of letters and numbers indicates availability across the different fare classes, then the right side provides most other data: departure time, arrival time, aircraft type, and flight duration. But the fare data is still missing. For that, Google Flights needs to pick a flight, pick a fare class, then enter another query for its price. But the GDS doesn't have that data itself. It seeks the answer from the Airline Tariff Publishing Company, which, similarly to the OAG with scheduling, is the one-stop shop for pricing data used by essentially every major airline globally. So once again, the GDS will repackage their response into this, reiterating the flight schedule, then displaying the base fare, the carrier surcharge, US passenger facility charge, security fee, and international departure tax to give a total $630.20 one-way fare on the February 8th British Airways Denver to London flight. This entire process is repeated for the United option, which gives Google Flights all the information necessary to populate this screen. But next up is booking, and that's even more involved. Regardless of where a booking takes place, with some limited exceptions, the user interface is just a translation tool to input a string of commands into the GDS. This sequence initiates the process of creating a passenger name record, or PNR, to which it will then input a phone number, the name of the person making the booking, then a precisely formatted description of the desired flight itinerary. After reconfirming availability and fare price, the GDS will then submit the PNR and return with this, the time limit for actually paying for the booking. At this point, the booking is confirmed. That seat is reserved and will stay reserved unless that payment deadline passes without payment. While these days customers typically pay immediately, in the background it's rarely required, but this delayed deadline gives an online travel agency like Expedia, for example, time to process and verify payment from the customer before actually paying for the ticket themselves, at which point it might become non-refundable, leaving the company in a tricky spot if the customer's credit card payment declines. But even before paying, Expedia will close out the transaction with the GDS, therefore sending the passenger name record to the airline, which will respond with a modified version including a confirmation number, which is then extracted and sent to the customer in a flashy, well-formatted email. The GDS and its associated systems were revolutionary for the airline industry. Not only did they make reservations a far less labor-intensive process, they made essentially every airline reservation system interoperable with each other. These days, it's fairly simple for airlines to sell tickets involving other airlines. They're all using the same GDS already, so the way United's internal systems interpret and modify PNR is the same way Lufthansa's would. Theoretically, United could sell you an itinerary connecting onto an American Airlines flight. They wouldn't because they don't have a commercial partnership with the airline, but from a technical perspective, there's nothing stopping them. And if something goes wrong and your United flight cancels, the airline can and occasionally will rebook flights onto American, Delta, and others using this system. But while the GDS was revolutionary, it hardly still is today. In fact, at airports around the world, when you step up to a reservations agent, chances are the other side of their screen looks like this. Still today, in 2023, the GDS is operated as a command line interface, the way computers worked before graphical user interfaces were popularized in the 80s. Command line interfaces aren't in and of themselves an issue, but in context, the difficulty is that using them requires legitimate creativity and skill. Let's say, for example, a customer is here in Denver, headed to Zurich, and their 1:40 p.m. flight to Chicago to connect onto the 7:10 overnight to Zurich just canceled, meaning they won't make their connection. A rebooking agent would start by querying the GDS for the next available itinerary between the two cities, and they would see there's a viable one connecting onto a 7:20 p.m. Swiss Air flight out of LAX. The problem is that the only two flights to LA that would make that at 1:36 and 3:55 are already oversold, meaning there's no seat available for the stranded passenger. So, according to the GDS, it's impossible to get that passenger on their way to Zurich until the next day. But just because the GDS says it's impossible doesn't mean it actually is. For example, an experienced rebooking agent would know that United also flies to John Wayne Airport in Orange County, about an hour's drive from LAX, so if desperate, the passenger could fly to there, take a taxi to LAX, then make their overnight flight to Switzerland. The GDS can't offer this as an option because it's not one that the airline would sell, so it's not in the system, but with this knowledge, an agent could individually book seats for each leg, then string them together into an itinerary in the PNR. The GDS also would know that United's 11:45 a.m. LAX bound flight was delayed until 1:30, meaning the passenger could still take that and make the connection. It also wouldn't suggest taking American's 4:10 p.m. flight to LAX as an option because Swiss Air and American don't typically ticket together, but in this exceptional circumstance, United could buy the stranded passenger a ticket on American through the GDS to continue their journey on Swiss. And this is only the tip of the iceberg. There are endless tricks to working with the GDS to solve problems, but experience is needed to know the right technique. The horrible truth this presents for both passengers and airlines is that constantly passengers are getting stranded when they don't have to be. It's down to the luck of the draw. Is the rebooking agent you're walking up to one that's worked there for 30 years and knows the GDS like the back of their hand, or have they just finished the limited required training to complete those simplest tasks? For passengers, this increases the frequency of getting stranded on the road, and for airlines, this increases the cost borne from issuing meal vouchers, booking accommodation, and paying for delay compensation when passengers don't get to their destination on time. And the limitations of the GDS not only create additional costs, but also prevent potential revenue. For example, Air New Zealand developed an innovative product where 3 successive economy class seats can be transformed into a short lie-flat bed called SkyCouch. That means that those seats can be sold individually, as usual, or as a set of 3 to 1 or 2 passengers. This sort of optionality breaks the GDS. It doesn't have a way of properly communicating or reserving these sorts of transformable seats, so on the GDS, SkyCouch seats are just displayed as occupied, regardless of whether they actually are. In order to book them, one has to go directly to the Air New Zealand website. For the airline, this leaves plenty of potential revenue on the table. For example, a huge portion of the airline's traffic is ticketed through United, since United is a major partner that feeds inbound traffic from across the US to Air New Zealand's long-haul flights out of LA, San Francisco, Houston, and Chicago. Those passengers can book and check in exclusively with United, meaning they would never have even had the chance to pay Air New Zealand for SkyCouch, and it's the same with passengers who booked through other airlines or online travel agencies. Airlines have been complaining about the GDS system for decades, and so there are an increasing number of technical solutions and workarounds to the GDS's constraints, but even those have their problems. For example, IATA introduced the new distribution capability standard, which allows for more complex back-end communication. But rather than serving as the solution to the GDS's shortcomings, it more so demonstrates what's truly at the root of the problem. 162 airlines, travel agencies, system providers, and others are certified by IATA as having properly integrated this new standard into their systems, or at least part of it. The core functions have pretty good uptake. For example, 156 of those have incorporated the NDC standard that allows for shopping for flights. But then you get to the more novel functions. SHPA N2 is a standard that allows for the sale of increasingly common unbundled ancillaries like in-flight Wi-Fi, lounge access, priority boarding, and more, meaning that, theoretically, it allows someone booking through Expedia to buy that in-flight Wi-Fi right in their checkout flow. But only 51 of the 162 are certified on this capability. And then you get into the really specialized stuff. NDC has enabled airlines to have interoperable dynamic pricing systems, meaning rather than working with the constraints of the GDS and ATPCO, which only allow for price updates a certain number of times per day, each fare will be customized for each individual consumer based on an algorithm's estimation of their price sensitivity. But to date, not a single airline is certified on this already existing revenue-generating standard. This is a familiar refrain. Airlines ask for more advanced systems are developed, then airlines don't use the more advanced systems because they decide the cost it would take to integrate them isn't worth it. And some airlines are going further, not only failing to implement new interoperable systems, but rejecting their use altogether. For example, if you search on Expedia for an itinerary between Denver and Long Beach, it'll tell you the best option is a one-stop trip through Phoenix on American, but there are actually 3 non-stop flights a day on that route. The problem, though, is that they're Southwest flights, and with limited exception, Southwest does not allow for booking through the GDS, meaning Expedia has no way to book a customer a ticket on the airline. Meanwhile, on Google Flights, which focuses on directing people where to book rather than booking itself, you can find Southwest schedules, which are filed with OEG, but you can't find fares. With no GDS sales, there's no reason to distribute fare information. This all means that nearly all Southwest bookings are done on Southwest's website, but the airline can customize and revenue optimize the booking process as they wish. The upsells are everywhere. Before confirming a fare, we get the pop-up outlining the benefits of the next most expensive fare class. On the following screens, there's the same upsell again, an offer for a $200 credit in return for signing up for their credit card, and an option to pay for early check-in, guaranteeing one of the best boarding positions. These upsells matter. In 2021, ancillary fees made up more than $4 billion in revenue for Southwest, and that ancillary revenue is raised when customers book directly and are offered all the upsells. And in addition to increased revenue, direct booking costs less. No paying for developers to integrate their systems with others, no paying GDS fees, no paying commissions to Expedia and others. Following Southwest's lead, GDS non-participation by budget airlines is downright common these days, and the full-service network carriers are increasingly working around it to strike up direct business and system relationships with major sales channels and partners. But this is fragmenting the industry. Airlines are innovating, which is exactly what the industry should be doing, but through this individual innovation are losing the collective interoperability that has led to the globally seamless travel experience that customers have come to expect. It's almost analogous to a reverse tragedy of the commons. Each individual node in the system would grow their revenue by investing in better interoperable systems, but only if every other node did too. If only one node invests, they'll spend money to create interoperability, but still lack partners to interoperate with, meaning no revenue impact and a negative cost impact. So, in this context, each node is actually incentivized to reduce interoperability to push consumers towards their own systems, which are better designed to increase per customer revenue than the interoperable ones. It's a strategic stalemate. And this can explain the broader issue as well. There's a strategic IT stalemate. When every airline's IT is equally bad, there's little competitive incentive to improve it. Why invest to improve to a level that the public doesn't even know is possible? Globally, the airline industry has just settled on a culture of good enough. The problem, from our outside perspective, is that airlines essentially act as public utilities these days. They're the only practical means of long-haul travel, and are also the only practical means for medium-haul travel in areas of North America, Russia, Australia, and other larger, less dense countries. When airlines slow down, people slow down, and therefore economies slow down. The US recognizes this fact by subsidizing the construction and maintenance of airports, and even more strongly by subsidizing airlines to fly to rural and remote communities, under the thesis that a lack of air travel options would hold back their economies. And countries also recognize this preemptively, historically treating the earliest airlines as government services and running them as state-owned enterprises. But in the century since, the trend has been thoroughly towards privatization, meaning the only real obligation is to the shareholder. So this is one of those all too common scenarios where there is a stark difference between what's good for the shareholder and what's good for the world. Therefore, it's pretty simple. Regulators need to decide whether airlines' IT antiquity is a problem for the public, and if so, do something about it. As many of you know, I travel constantly. I'm on the road more than I'm at home, and one thing that I found is crucial to making that level of travel sustainable is having self-improvement routines that I can do both at home and on the road. That means going to the gym, on runs, and a less common one that I've really grown to love is using our sponsor, Brilliant.org. That's because Brilliant has these really interesting, well-designed courses on STEM subjects that probably seem way too hard to learn independently. Crucially, these courses are designed so you can move through them in bite-sized chunks, so while I'm at home, I might make some progress learning gravitational physics while waiting for a call to start, while on the road, you might find me doing the same while waiting for the plane to board. And what's amazing about it is that if you just do that